Hello, good day everyone. We are going to talk about areas today in geometry. We know several areas. We are going to talk about the area of a triangle and some special quadrilaterals like a parallelogram, a trapezium and a rhombus. But we are going to do it in two ways. One is with the help of models as usual and the other is with the help of paper folding. So we will do it in two parts. The paper folding part will be in the second part. So today we go ahead with the models. Now, here is the model of a triangle. And before I put it there, I will show you that it is made of a different material. You must have observed that. And the different material is foam or sponge, maybe they call it. The advantage of using this material is that we can cut it with a paper cutter by ourselves, and we don't have to depend upon a carpenter or anyone. Like cardboard, it will not bend, it will steady. And the second thing is, it comes in different colors. I have two colors as I showed you just now, but it comes in different colors. You don't have to choose different colored papers or paint on the wood and so on. Now, starting with the triangle, we want the area of the triangle, and we know that the area of a triangle is 1/2 BH, where what is B and what is H? It is like this. B is the base and H is the height. I'm not going to draw it there, but H is the height of the triangle. It is the altitude from the opposite vertex onto the base. And the area is supposed to be 1/2 B into H. We are going to verify this. What we do is we take a triangle. We take the two midpoints of, this is the base. We take the two midpoints of the two other sides. So if this is our base, this is one side, this is the other side, and we take the midpoints. And what we have done now, as you can see, from the midpoint we have taken a perpendicular on the base in both the cases and cut along that perpendicular. The cut we shall put, of course, as dotted line in a different color. So, this is the model of the triangle. A triangle, the midpoints and the perpendiculars to the base. And cut along these two perpendiculars, we have three pieces. You will see, excuse me, we will not make a separate part at the end for making the model. It comes here and we have simply to start with the triangle and put the two cuts. Now, our aim is to show that the area of this triangle is 1/2 the base into height. We take this little piece, turn it around and put it here. Same thing on this side, turn it around and put it here. As you can see, this is a rectangle. Now in this rectangle, in all the areas, we are going to assume one thing, and that is that area of a rectangle, that it is equal to the length into breadth. So, whether you call this length or this, it doesn't matter, it is length into breadth. So, this length into this length. Now, we don't want the area of the rectangle, we want the area of the triangle in terms of B and H. We have got something already. Look at this length. Do you see that it is exactly the height? So, one side of the rectangle is exactly the height. What about the other side? This other side, as you can see, is also equal to this, which is the length of the line segment joining the two midpoints. As we saw that it last time, it is exactly half the base, and the base was here. So, what we have now is, this side was H and this side is 1/2 b, and therefore we have 1/2 base into height. That takes care of the triangle. And now the parallelogram. Here is a parallelogram. We know that for a parallelogram, I will try to draw the figure as it is shown here, this way or that way, whatever. This is the parallelogram, and if we call one side this as base, then any line or the distance between the two parallel lines is the height. Wherever you draw, it's immaterial. And the area is base into height. Now we want to show this, and for that purpose, what we have done is, here is the parallelogram. This is the base, or you can also take the two sides are equal. So the length of the base is either here or here, wherever you take. From one vertex we have drawn a perpendicular to the base, and that we know is equal to the height of the parallelogram. We cut along that. So that's what we do here now. From here, we draw a perpendicular, and we know that this is the height now. The green is the height, and we have drawn it in green because, as you can see, we are going to cut along this altitude. Now the model is ready with us, simply by taking one cut. To verify the result, we take this and shift it and put it here. Nice. What's nice about it, we have got a rectangle and we know its area. The area of the rectangle is length into breadth. We want in terms of the parallelogram. As you can see, this was precisely what we had here. It was the height. So one side of the parallelogram is the height, of the rectangle is the height of the parallelogram. The other side is this or this. As we have seen, it is the side of the parallelogram, and therefore the area of the rectangle is height into base, and that is BH. Okay, next one. The next in line is trapezium. Where I am placing it, you can see how I have cut it, because the two parts are separate. This is the trapezium, where these two sides are parallel. Now, what is the formula for the area which you would like to verify? It is this. If the two parallel sides have length A and B, and if the height of the trapezium is h. Now what is the height? It will be the distance between the two parallel lines. What we are going to do now is this. I am not going to draw it. Here is the trapezium. What we have done is, to prepare our model, we have taken the two slanting sides and taken their midpoints and cut along the line segment joining the two midpoints. So we do that here. Midpoint of this side and midpoint of this side, and we will draw it in a dotted line because we are and green color, because we are going to cut along it. So our model is ready. We took the two midpoints, cut along the line segment joining these two midpoints, and have to verify the area. Oh, what is the area? The area for this, if height, wherever we draw it, we call it h. The result for the area is 1/2 A into B. I'm sorry, A plus B is the sum of the two parallel sides into h. This is what we are going to verify. Okay, we have the model. As in case of triangles, take the upper part, turn it around and put it here. Now we have cut it from half, so these two are equal. So this goes in line. This is parallel to this, so these two are parallel. These two will also be parallel because the angles will be equal, and therefore this is a parallelogram. Now the area of this parallelogram we have just seen. It is 1/2 B into H. I'm sorry. The area of a parallelogram is B into H. But that is for this parallelogram. We want for the trapezium. So now, what is H here for the parallelogram? It is this much. And as you saw, it is half the height of the trapezium. And therefore, the height of the parallelogram is half the height of the trapezium. So, it is 1/2 H. So far as the trapezium is concerned, here it is, the height of the parallelogram is 1/2 the height of the trapezium. What about this? This is the side of the parallelogram. This side, as you can see, this was the smaller side here, A, and this was the bigger side, B. So the whole is A plus B, and so in terms of the trapezium, it is 1/2 H into A plus B. So that takes care of the trapezium. And now to the rhombus. And draw the rhombus first. All the sides are equal. It's a parallelogram. All the sides are equal. It has all the properties of a parallelogram. Besides, because of all the sides being equal, there are some extra properties, and one of the very important ones is that the two diagonals of course they will bisect, but they will bisect at right angles. Now you have seen that I have drawn a green dotted line, so you know what it means. It means that we are going to take this parallelogram and cut it along the diagonals. Okay, let's take the parallelogram. And it won't stay up straight, so I'll put this little piece here for support. The green part is not a part of the parallelogram, it is only for support. So here is the parallelogram, or rather rhombus. You can see it is just like this. The two diagonals, you may not be able to see directly, but here is one diagonal and here is the other diagonal. They are both bisected at right angles. And normally we call this B1. This is the small one is B1, the bigger one is B2. And the formula for the area is, in case of rhombus, of course it's a parallelogram, so we can take it as BH. But because it is a rhombus, it has something special, and that is, if B1 and B2 are the diagonals, its area will be 1/2 B1 into B2. And let's verify this. You can see that these are 4 congruent triangles. By cutting them along the two diagonals, we have got 4 congruent triangles. And now, the total area is the area of all the 4. What we can do now is this. What did we do? We arranged them side by side, all 4 of them, 2 below and 2 above, and forming a long rectangle. Now we know the area. It is length into breadth. But in terms of the original rhombus, how much is this length and this breadth? Now you can see this two are same over here. And here you can see that this is part of the rhombus, this is the big diagonal, so this is D2. How much is this? Well, the whole rhombus was like that. And this is half the small diagonal, so this is D1. And therefore, I'm sorry, the whole was D1, so this is 1/2 D1. So this is 1/2 D1 into D2, 1/2 D1 into D2. And now you may say, I don't want to arrange like this. Why not like that? Okay, go ahead. What is the area now? The area now is, as you can see, the whole big one here is the small d1. The rhombus is part of the rhombus is here, the other is here. This is d1, and this, as we had seen earlier, the whole was d2. This, I'm sorry. Yes, the whole was d2, and this is half d2. So it is d1 into 1/2 d2. That is again 1/2. In one case you get half of d1, in the other you get half of d2. Eventually, of course, it's mathematics, it has to be the same, 1/2 d1 d2. Okay, that takes care of the models. We have seen how to make them. You can try, if you get this stuff, try to make them yourself. And you can use it for other models also, which we have made for algebra and so on. Those with paper folding we shall take in the next session. Thank you.